Okay. So today we're looking forward to solving equations and inequalities with graphing. Okay. And the question we're looking at is how can you solve with graphing? And at the end of the section, you should hopefully be able to use the graphs and tables to find solutions to algebraic equations and inequalities. Okay. And I'm going to skip over the second one. We're going to go straight to number 3 here.
Which one is that? Oh, glad.
Yep.
I didn't finish.
So yeah, we're on lesson 1.5, and we're looking at slide 3. We're asked, how can you use a graph to solve this equation? So, any ideas how to graph either of these?
You can get x on one side and then plug in for x.
Well, that would be solving it algebraically. If I got it to one side, right? But what if? What's that? So we want to graph a line, right? So what this is saying is that these two expressions are equal, obviously. So any values of x that make this side 5 would be a solution. So if I want to solve this by graphing, we can kind of set it up like a systems of equations. I could say one equation I could graph is negative 3x plus 20, and another equation I could graph is 5. So I have y equals negative 3x plus 20, and y equals 5. And when I graph those two on the same coordinate plane, they have an intersection point. So that intersection point, what is the x value there? 5. So what do you think that x value of 5 is for this problem? X being 5 is the only point on the graph where it makes those two equations equal. And that's what we wanted to know. We wanted to know what value of x makes this equal to 5. So we graph the line 3x plus 20, right? Intercepts at 20, and it has a slope of negative 3. Y equals 5 is just that straight horizontal line. And the intersection point is where the solution is. Right? So we've done these algebraically. If you're going to solve this algebraically, subtract 20 from both sides, divide by negative 3, and you get 5. But now, we're looking to do the same with graphs. So, if I see an equation like this, I have the absolute value of x minus 4 equals 1/2 x plus 1. That one could be solved algebraically, but with some difficulty. So what we would do to solve this with graphing is you just graph both sides of the equal sign as an equation. So if I graphed y equals the absolute value of x minus 4, right? That's, if we remember our transformations, that's just the absolute value graph shifted to the right 4. So I have that blue graph as the absolute value of x minus 4. And then if you graph the other side, y equals 1/2 x plus 1, intercept at 1, going up 1 over 2, you'll get that orange line. So then the solutions to the equation are, again, my points of intersection here. The x value where they first intersect is 2. So if I plug 2 into this equation, the absolute value of 2 minus 4 equals 1/2 times 2 plus 1. I want to know if that's a true statement. So 2 minus 4 is
-2.
-2. And the absolute value of -2 is +2. And then on the right side, a half of 2 is 1, plus 1 is, so is that a true statement? Yes, it is. So I know that x equals 2 is one solution. And then if I look down here at the next intersection point, they intersect when x is 10. So I can do the same thing. To see if that's a solution, I can plug it in. So we can say 10 minus 4, and then 1/2 times 10 plus 1. So the absolute value of 10 minus 4 is 6. Half of 10 is, plus 1 is, true statement? Yes, it is. So I know that is my other x value. So this method,
Wait, where'd you get 4 from? Oh, that's just the equation I gave you.
Yeah, that's just the given equation. Yep, that's just the given 2 equations. Okay. And I just plotted both of them on the same coordinate plane, and I looked for where they intersect. Okay, does that make sense, what we're doing? Looking for the intersection point of 2 lines? Or might be a parabola, might be an absolute value. Okay, but you're graphing and you're looking for the intersection points. Okay, so on the next slide,
What's that?
that is, so we're still on 3 of 10, but we're on the third part. So it says, try it. Use a graph to solve the equation. So I want you guys to use this Desmos. What are you going to type in there?
5x minus 12 equals 3.
So if I just typed in 5x minus 12 equals 3,
Minus 12.
what I wanted, remember what we did in the first 2 problems? We set each side of the equal sign as a graph. So I have 5x minus 12 is one graph, 3 is my other. So if you type that in, y equals 5x minus 12, and y equals 3, what is the x value of my equation that would be the solution?
4. 3.
1, yeah, so it's a little hard to see on my screen, and you might try it better on your screen.
Yeah.
But it's 1, x equals 1, x equals 2, x equals 3 is my solution, which I could plug in and try. 5 times 3 is minus 12 is, so it's a true statement. I know that x equals 3 is my solution. So I think there's one more try after this. Right? Now using this given equation, what would I set my first equation to be?
Negative absolute value of 2, x minus 2.
Exactly. So what equation is going to be the left side? The negative absolute value of x minus 2. And then the other equation is going to be the right side of the equation. So negative 1/2 x minus 2.
Wait, how would I do the half?
So you can use the key right above, like the backslash, is the division. So, what are my 2 solutions here? My graph is going up by 2s.
-2.
Well, where's the first intersection point for x? Where's the x value where they intersect? They intercept at 0. So if I plug in 0 to this equation, 0 minus 2 is?
-2.
The absolute value of -2 is?
2.
Put a negative in front of it, it goes back to being a -2. If I plug 0 into this, 0. So -2 equals -2, that's true. So I know x being 0 is one solution. Where's my other x value where they intercept? Down here, it looks like they intercept at 8. When x is 8, it looks like they intercept again. So, we'll try the same thing. If I plug 8 into this, and so 8 minus 2 is 6. Put a negative in front of it. Half of 8 is, but make it negative because a negative times a positive. So -4 minus 2.
-6.
-6. So -6 equals -6 is a true statement. So x equals 8 is my other solution. Any questions about what we're doing to get those answers? Just finding where they intercept the other graph. Yep. And luckily, the graphing calculator has a way of doing that for you, calculating the intersections. And also, Desmos is very nice about giving you the intersections. But we also want to talk about solving inequalities. This says we want to solve x squared minus 4 is greater than 0. In other words, I want to know all of the values of x that would make my function positive. Okay. So, if I want to use a graph to solve this, I can graph that parabola, x squared minus 4. So, you can graph it either by looking at it as a transformation, right? It's the basic parabola, move down 4 units. Or you could plot it in a graphing utility, or pick points to plot. But if I graph that, I want to know where is it positive at? So we've kind of done this before when we were talking about the key features of functions and we were asking where is a function positive or negative. We said it's positive where?
-2 and 2.
Well, that's where it changes from positive to negative, right?
Negative.
Is it positive inside that region or outside of it? Outside of it, it's positive.
So
Right.
-2, and 2 is -14.
Exactly, right? So this graph, if it's, when we're talking about whether the function is positive, we're talking about where the y values are positive. The y values are the function values. So we're asked what y values, this is asking what values of x give me positive y values. Okay? When is this greater than 0? So all before -2, my y values are greater than 0. After 2, the values are greater than 0. Between -2 and 2, the values of my graph are below 0. So the solution to where is x squared minus 4 greater than 0, in interval notation, would be from -infinity to -2, and from 2 to infinity. But we also want to be able to write that as an inequality. So when x is less than -2, or when x is greater than 2, is the solutions to that problem. So when you're solving an inequality,
It's just asking us.
it's asking for like a range, because if it was saying where does x squared minus 4 equal 0, that's where you get like one answer, or two in this case. But with an inequality, you get a broad range of answers because one graph is bigger than the other? Okay, so using a graph to solve an inequality again, this time we're looking at a word problem, our favorite kind of problems. And it says a motorcycle is 40 miles ahead of the car, and it travels at about 40 miles per hour, but the car travels at a rate of 60. We want to know, when is the car going to be ahead of the motorcycle? So, if I want to solve that, I need graphs that represent their speed. So the car is traveling 60 miles per hour, and the motorcycle is traveling 40 miles per hour, but it had a 40-mile head start. So I can set up those two equations, and I want to know, when is the car's distance greater than the motorcycle's distance? Okay. So does it make sense how I set up those two into an inequality? So now I can graph both sides of that inequality. And if I do, looking for, if the car is represented by blue, the motorcycle is represented by red. I have my distance, here's my y's. I can see that the blue graph is above the red graph. Right? The car's graph is above the motorcycle's graph after 2 hours. So if they intersect at 2, every point after that, the car is ahead of the motorcycle. So if you want to write it as an equality, you would just say for all x's greater than 2. Or anytime after 2 hours, the car is going to be faster than the motorcycle or further ahead. Alright, so on this try it one, I'm going to graph the left side of this equation. Right? So on your Desmos, I encourage you to do the same. You have y equals x squared plus 6x plus 5. So if I'm looking at this graph, what are my intercepts here? Yeah, it's going through it at -1, it intercepts, and over here at -5, it intercepts. Now remember what I said about the intercepts weeks ago. The intercepts are the only time a function changes from positive to negative. It has to go through 0 to go from positive region to the negative region. So -5 and -1 are my two boundary points that I'm going to use. And here we want to know, when is this graph, when are the y values of this graph greater than or equal to 0? So is that between these 2 points?
After, and it would be -1 to positive infinity.
So yeah, it would be,
Or -5.
it would be on the outside that this graph is positive, right? This region is positive. Right? That's a positive region. This is a positive region. Down here, these are all negative y values. So from -infinity to -5, and from -1 to positive infinity. But if I want to write that as an inequality, I'm saying x is what compared to 5? Yep. Exactly. I'm saying for x is less than -5, or x is greater than -1. But we have to be careful too, because this says this can be greater than or equal to 0. So can I include these points where it is 0?
Yeah.
I can.
So it would be, yeah.
How do we do that?
I don't, yeah, right.
Okay. So you don't have to type that in, like as long as you graphed it and you can see. Okay. X less than or equal to -5 because it's 0 there and before it. X greater than or equal to -1 because it's 0 there and after it. Okay, on the next one, using this inequality,
So then you just find where it meets.
so yeah, if I want to, first I would say y equals x plus 3. And then we would do y equals 7 minus 3x. And then we're asked, where is the orange graph greater than the black graph? Okay. So where is their intersection point?
There's one on, is there one that was,
Yep.
like, what was like after 2?
No, you're right. They intersect at that point 1, 4. So before 1, so ignoring this side of the equation, before 1, which graph is above the other? The black graph or the orange graph?
I mean the black, my bad.
The black one is, right? It has higher y values than this one does.
Mine's
So before 1, 7 minus 3x is greater than x plus 3, which I don't want, right? I want the orange one to be greater than the black one. So then after 1,
My graph is like,
can you see my graph up here?
no, that's why I'm not getting it.
No, it's the same graph, it's just your zoom is a little different. But this point where they intersect, the x value is 1. After that intersection point,
Orange is further.
orange is higher than the black graph, right? Which is what I wanted. So is my solution before 1 or after 1?
After 1.
It's after 1. So for all x's greater than 1. And because this is not greater than or equal to, this is not greater than or equal to, it's just strictly has to be after 1.
It wants us to type in full sentences. I'm not doing that.
Yeah, you don't have to do that. Just graphing it is fine. Okay.
Oh, you skipped it.
Yeah, we skipped that one. It wants you to use graphing technology to approximate these solutions. And the method it has is plugging in tables of values closer and closer to the solution. But in our case, Desmos and the graphing calculators do a really good job of providing us with that estimate, so we don't have to go through those extra steps of trying to do the estimate ourselves. All right, so we're done with this today. You can close out of this.